So, I'd like to welcome you to the first annual EMDS Online User Forum. My name is Keith Reynolds. I've been directing EMDS development from the very beginning. Also listed on the slide are my colleagues who are part of the EMDS consortium. These are companies that contribute to the functionality of EMDS. So first, a little bit of background. EMDS is a general application framework for designing and implementing knowledge-based decision support applications for environmental analysis and planning. It integrates a variety of GIS platforms now, as well as a variety of knowledge-based reasoning and decision modeling technologies to provide decision support for a substantial portion of the adaptive management process in ecosystem management. To give you a little bit of history, the first production release of EMDS was in February 1997, so it's a little over 22 years old at this point. The first three versions of EMDS were produced under contract with the Environmental Systems Research Institute, and that development spanned 1995 to 2002. Subsequently, EMDS development continued under the stewardship of the University of Redlands from 2005 to 2014. During this time frame, we produced versions 4 and 5, and also the EMDS consortium itself was organized in this time frame. And then finally, the development has continued independently since then under the consortium. In this time frame, we've produced in the last couple of years versions 6 and 7, with version 7 just being released, and many advances being introduced in the last couple of versions, by the way. On this slide, I list some of the major applications that have been developed with the EMDS over the years that I've been involved with. I'm not going to go through the whole list, just to focus on the last few in these examples. Begin with the wildland fuels project. This was to manage wildland fuels for both the U.S. Forest Service at the Washington office and regional levels, as well as all the agencies of the U.S. Department of Interior. The next major project that came along was managing critical loads associated with atmospheric sulfur and nitrogen deposition. This work was done for the U.S. EPA and spanned the entire extent of the Southern Appalachian Mountain region. A really notable one that I would recommend having a look at in the publications I'll refer to in a minute was the Integrated Landscape Restoration project that was done on the Okanagan-Wenatchee National Forest. You can find this on the Wikipedia site down below. And then finally, since about 2011, there's been a large U.S. Forest Service national program working on the National Terrestrial Condition Assessment. This is designed to assess ecosystem integrity on all U.S. Forest Service lands nationally at the national scale, regional scale, and national forest scale. There are many other applications of EMDS that you can find, and most of these you can find on Wikipedia at the site indicated down at the bottom of the page. A quick introduction to the consortium. The Forest Service has been the lead in development from the very beginning, of course. Mountain View Business Group came along later, but is now responsible for what we call the EMDS core functionality. This is basically what ties together all the functionality of the other analytical engines in a GIS environment. And then the next four, rules of thumb, InfoHarvest, Logic Programming Associates, and Bayes Fusion, are all private companies that have contributed particular kinds of analytical engines to support decision modeling in EMDS. Quick overview of the agenda. The consortium presentations are probably going to run a bit longer than 50 minutes. They'll span about probably an hour and a quarter. Because those are running a bit long, we have foregone user presentations. In the last few sections, we're going to look at future directions for EMDS development, and then particularly important, time for user engagement to basically look for feedback from you on assessment of the current EMDS technology and also what you'd like to see in the future. And then we'll wrap up at the end with some brief final thoughts. So here's the agenda for part one. These are the consortium presentations. Steve Paplanis is going to start out with a kind of overview of the EMDS architecture as it currently exists. I'm going to talk about the latest features of version 7, and then the next four, the NetWeaver talk, CDP, VisiRule, and Genie. These are presentations by each of the consortium members on the different analytical engines that support EMDS these days. At the end of that, Steve Paplanis is going to wrap up with sort of an end-to-end demonstration that integrates a number of these technologies into one application, and then we'll wrap up with Q&A, look at future directions of EMDS, and a longer group discussion on the topics I mentioned earlier. And I'm going to skip this slide because it's going to get covered in some respects later on. Anyways, so I do want to end up on this point. EMDS 7 now is a state-of-the-art industrial strength enterprise solution for environmental analysis and planning. Thank you.
Welcome to a technical introduction of EMDS. My name is Stephen Paplanis of Mountain View Business Group. We are the lead developers and architect of the EMDS framework. The EMDS framework is made up of 4 tiers: the front-end clients, the middle tier with workflow engines and business logic, EMDS engines including NetWeaver, CDP, VisiRule, and Smile, and the data storage tier. EMDS has several clients that have been released or planned for release in the next month. These include both desktop and cloud editions of EMDS. Administrative tools for managing the new workflow system are available in both desktop and web clients. At this time, we have 2 editions for EMDS. EMDS 6, which will be our long-term stable edition, and EMDS 7, which will have rapid release cycle with the latest and sometimes experimental features. Our plan is to always have a long-term stable version that have no additions except if there is a critical flaw or issue, and a fast release version that will allow us to add new features and get feedbacks from users to approve it. Each year, we will update the long-term edition to catch up with the fast-track version after sufficient use and feedback is gathered. Our scheduled release for EMDS GIS clients are ArcMap 10 add-in, version 7 with workflows, and an updated version 6 on April 15th. Our first entrance into QGIS space will be a QGIS 3 plugin. This version is currently in alpha testing. On April 30th, I will open up beta testing to the general public to get feedback and hopefully launch the final version by June 1. A Map Windows 5 edition will allow for an open source Windows-based GIS experience will be released on May 16th. A standalone edition based on .spatial, providing a workbench to leverage the Power EMDS framework in both spatial and non-spatial analysis, will go into open beta on May 20th. Collaboration Manager is our first web-based EMDS project viewer that will allow teams to view and run EMDS projects and models and to annotate them. This is planned to be released on Azure Government by late September. EMDS middleware contains the business logic services, which include workflows, requested processing, semantic processing, and access to statistical APIs. The EMDS processing services are all the engines which EMDS can leverage. Each of these services are wrapped with an EMDS service wrapper, which allows each engine to function properly in multi-user and multi-thread environment. The EMDS data storage tier is where all the data and metadata for EMDS and its projects are stored. The Provenance engine tracks all activity and logs each step that the user takes while using EMDS, so that any analysis can be reproduced and traced through. Thank you. Are there any questions on the technical aspects of EMDS?
So, in this section, we're going to talk about some of the more important of the latest features in EMDS version 7. Again, my colleagues on this are listed below. I'm going to start out by looking at the current platforms supported in EMDS version 7. ArcMap has been a component of EMDS from the very beginning, but we've also added recently, we are in the process of adding QGIS, Map Window, and Spatial, all of which are open source GIS alternatives. A little further out on the horizon, we are planning on a standalone workbench, which Steve will be talking about a little bit more later, and a web-based enterprise edition, initially based on Azure Government Cloud. Databases supported currently include SQLite, SQL Server, and Oracle. A little further out, we'll be adding, of course, Azure SQL Server to support the cloud environment, and Postgres. The engines are the core analytical tools in EMDS. And these include NetWeaver, which has been a part of the EMDS from the very beginning and supports logic processing. And NetWeaver was selected from the very beginning because its capability to support design of very large, complex, abstract models. In 2002, we added Criterion Decision Plus, or CDP, which provides multi-criteria decision analysis. This supports both strategic and tactical planning in version 7. Recent additions include Visirule, which provides prologue-based decision trees, which allow for more complex reasoning, particularly suitable for tactical planning. And then also Genie. This brings Bayesian Network capabilities to EMDS. And it should be pointed out that the workflow environment of EMDS allows invoking any sequence of these engines in any order you want, as many times as you want, to support almost arbitrarily complex analytical problems. In terms of the architecture, for some who are not maybe that familiar with EMDS, here's a quick overview. It supports multiple assessments. This is important because most environmental problems usually can't be solved by addressing the question at any one single scale, but instead, oftentimes, 2 or maybe more scales are necessary to address the full scope of an environmental analysis. And these assessments are defined by a set of layers and spatial extents that are defined by the users when they build a project. Within assessments, there can be multiple analyses. This is useful because the analytical engines that we looked at in the last slide can be run either in parallel or in series with each other within an assessment. Also within an analysis, in the NetWeaver context, we can run multiple scenarios, and these basically deal with what-if questions, such as what if we altered the data? How does that change the outcome? Or what if we change the structure of the model? How does that change the outcome? And then finally, the analyses and scenarios that are generated can be compared with the new change detection utility that we've added in version 7. To complement the analytical engines that we looked at a bit ago, we have scripting tools including R, JavaScript, Python, and C#. The tasks for these can be inserted anywhere in a sequence of analytical tasks in a workflow, and they're designed to support some basic operations such as data analysis and data summarization, or data transformation to move information between from the outputs of one analytical engine to another. So back to workflows. EMDS is in fact built on the open source Windows Workflow Foundation, and this supports task sequencing via flowcharts, sequential diagrams, and state machines. Our workflow environment leverages an earlier technology called Trident. This was an open source workflow solution and editor originally developed by the National Oceanic and Atmospheric Administration and was also likewise built on the Windows Workflow Foundation. EMDS in fact uses several of the UI and provenance structures from Trident. In terms of the workflow engines and editors within Trident, the activities can be programmed in either Visual Basic or C#. Also there you can call external scripts written in R, Python, or JavaScript. And we will be adding a little bit in the future both KNIME and Wexflow, which are alternative workflow environments that support in particular data processing and statistics with R. Somewhat further on the horizon, we'll be adding support for map publishing services, including ArcGIS Online and Map Server, which is an open source alternative. We'll be developing a web-based enterprise edition, a semantic editor, which allows for reading and implementing ontologies in the decision support environment. And then a couple other things, PowerShell commands for batch workflow processing, and an EMDS workbench for spatial and non-spatial analysis workflows, which again Steve will be talking about a little bit later. Thank you. And make this available on the EMDS website in a little while. So next we're going through a sequence of talks and demos on the various analytical tools, starting with NetWeaver, then CDP, then Visirule, and then G. And we'll wind up with a presentation from Steve Paplanis on putting this all together. So I'm going to try and do this right this time, just a minute. So hang on.
Hi, I'm Bruce Miller from Rules of Thumb. We're the ones who created NetWeaver. I guess I get to go first because NetWeaver was the first EMDS engine. At the start, EMDS wasn't much more than just a NetWeaver-powered ARC extension. EMDS has grown a lot since then, and so has NetWeaver. Back in the late 80s, we had knowledge engineering sessions where we would get together with a bunch of scientists or other domain experts, and we would brainstorm on how to interpret ground conditions from basic data. The immediate product of these sessions was stacks of dependency networks written out on flip charts. It was up to some of us unfortunate coder types to convert these hand-drawn scribbles into readable logic scripts that our engine of the time could use. Well, you hand code a few of these and it's not too bad, especially if they don't change. But after a while, you have lots of them, and worse yet, you have to make lots of edits. In late '91, we picked up a contract that involved coding hundreds of hand-drawn interlinked dependency networks written by a colleague, and every week he'd send me a fat manila envelope stuffed with the new ones, and worse yet, changed ones. So we created NetWeaver Developer to automate the process. In EMDS, NetWeaver is primarily used to evaluate some condition on the landscape, but that's not all it's good for. Some of the applications we've worked on utilizing NetWeaver are a tool to predict Siberian moth outbreaks, a tool to rank wheelchairs' suitability for a given client, and another to optimize the chosen wheelchair for the client's environment, a tool for assessing the readiness of the 100 or so countries who deal with desert locust outbreaks and to help them build realistic contingency plans, and a companion tool that aggregates regional readiness and identifies systemic problems. A tool to evaluate and identify sub-Saharan communities that were likely to succeed at community-based natural resource management and to identify what they need to do to improve their success rates. A tool to identify soil classification from lab tests to the peatone level. A tool to diagnose honeybee issues and provide other management assistance to beekeepers. And a tool to help rank budget line items as to the relative bang for the buck. So back to those dependency networks I mentioned a minute ago. Here's one from the Chuacon knowledge base that will be referenced in a later presentation. It represents what it takes to have biophysical factors of a stream reach in good condition. It combines results from 5 supporting topics, antecedent dependency networks, in NetWeaver parlance. In NetWeaver, the dependency network is the fundamental building block of a knowledge base, or as some call it, a logic model. A dependency network in its simplest form is a graphical representation of the relationship of data to some condition, expressed with primarily, but not limited to, Boolean operators to define that relationship. In this dependency network, there are 5 topics, dependency networks in their own rights, connected to the top through a Boolean AND node. They in turn work their way down to basic data, so you get more fundamental towards the bottom until you get down to the raw data. And you get more interpretive or abstract as you approach the top. That AND node in the middle is kind of special. In classic Boolean math, all 5 topics below it would have to be true for the overall topic to be true. And you would need to have all those supporting data just to get started. But by using fuzzy math, we can work with shades of true or false, in effect evaluating on a continuum. NetWeaver takes it a step further and will evaluate expressions even in the absence of data. Of course, NetWeaver will let you know how much more data is needed to fully support its result. A key feature of dependency networks is that data needs are dependent on what data you already have. For example, if we input a temperature that is beyond this acceptable range, making the water temperature topic go false, the AND node will have all the data it needs to do a complete calculation. So when any node feeding the AND node is false, the AND node will be false and will be fully satisfied. However, if we change that temperature to an acceptable value, the water temperature topic now shows fully true, but the AND node now does not have all the data it would like. In fact, it reports that it still lacks 80% of the data. This is represented visually by the AND node's faded out color. And here is what you would see if you have a water temperature that isn't perfectly good, but isn't the worst. What may not be obvious at first is that we can use this feature to optimize our data collection. As you know, data comes with a cost, and some data comes pretty cheaply while others can be quite costly. So start with the cheap data, the stuff that's probably already in your GIS. Then let that inform what data should be collected in any given place. Remember though, the data needed to be collected will differ from place to place based on what is already known there. Let me mention something about color schemes in NetWeaver. NetWeaver Developer defaults to what we call a fuzzy stoplight coloring scheme. Red for false, green for true, yellow for undetermined. Values in between are ramped between those colors, and then the colors are faded towards white as their missing data influences increase. This means that a white node means it doesn't have any data, so it can't really decide anything. There are a couple of other color schemes available if this one doesn't meet your purpose, and in EMDS you can use whatever color scheme you like. I guess by now you've figured out that NetWeaver uses fuzzy math. Even without the benefits already mentioned, fuzzy math is a good fit for describing natural processes. Nature has lots of smooth transitions from one condition to another. Are you really fully mature on your 18th birthday and not at all on the day before? Obviously, your adultness is something that happens over time and is not as abrupt as a legal system would have us believe. Fuzzy math is also tolerant of our limitations to know precisely how to describe and measure nature. Is that stream too acidic at a pH of 6.8, or is it 6.85? Fuzzy math is tolerant of small differences in input. Fuzzy math helps us out in another, less obvious way. Before fuzzy math, we would have to build a dependency network to describe each category of condition for the topic, like poor, moderate, and good, or very low, low, medium, high, very high, etc. In practice, that gets to be awfully complicated, especially in the middle value conditions. We learned early on to define only the end condition, usually the optimal condition, rather than trying to define multiple categories of the condition. We use the fuzzy value to inform us how close we are to that end condition. In this case, how good is the stream condition? Now let's talk briefly about another feature of NetWeaver that can be really important, especially in collaborative projects or projects that span multiple data sets collected at different times or by different methods or with different interpretations. Data drives all of our analyses and all of our projects. We want the best data we can get, but we can't always get what we want, but maybe we can get what we need. NetWeaver has a node for that, the sequential OR. In simplest terms, the sequential OR takes the value of the first node under it, left to right, that has sufficient data. In practice, you place the sources in order of their preference, left to right, with the preferred source first and the least last, maybe even a default value, if that makes sense. For each of these nodes, you set the weight of the node to reflect the minimum amount of data you will accept, 100% being the default. In this example, the dependency network defines when a lake is potentially acid deposition impacted, or in other words, it's affected by acid deposition and not by some other acid source such as volcanic activity or decaying vegetation. It uses acid neutralizing capacity, sulfates, nitrates, dissolved organic carbon, and lastly, pH in its evaluation. A direct sampling on-site of the pH was preferred, but it wasn't always done. What's the next best available surrogate? Sum of base cations, and after that, a measure of conductivity. So in a perfect world, you'd have all three of the pH indicators, and the pH portion might look like this. Here it is using only the directly measured pH value. It ignores the other two. Now, if the directly measured pH value is missing, it will interpret from the sum of base cations. And if both pH and sum of base cations is missing, then it'll interpret from the conductivity measure. So in practice, the sequential OR is a data selector that automates getting the best available data for your project. NetWeaver is a robust tool that has evolved over the years to solve real problems. It has many features that we did not cover here today, given our limited time. But I tried to cover a few of the more important ones that I think might be useful to you, especially early on. We have an online help system with many video tutorials to help you get started with NetWeaver, and there are a bunch of more advanced topics there as well. Well, that wraps things up for me. Thank you for participating. Once again, my name is Bruce Miller. I can be contacted through the Rules of Thumb website or via email at bjmiller@rulesofthumb.com or just bjmiller@gmail.com. Thank you.
Okay. Stop again, take a pause, see if anyone has any questions about Bruce's presentation on NetWeaver. And again, if you need help, raise your hand. I can enable your mic. Okay. Go ahead, Phil.
It looks like Philip has a question.
Yes. Go ahead, Phil.
We just got a question from Eric, wanting to know if I have plans to make updates or changes to the user interface. Not really. I'll take suggestions. The issue is I don't sell enough copies to to make it worth a major overhaul, and I also feel that most people don't like to see big changes in software. They unless you're using something. Let's just say a lot of changes sometimes complicates things, and if somebody presented a good use case for me to modify things, I'd take it under consideration. But as the more direct short answer would be not at the present.
Okay, thank you.
We got another question coming, it looks like. Well, we have used it for other purposes. Probably, I mean, most of them have been because that's the fields I've worked in. So that's where I had the contacts. That's where we used it. And it's kind of hard to break into new fields, or maybe you don't even want to all the time because you don't want to have to learn a lot of new things. But we did things like wheelchair prescriptions. We looked at building codes so we could automate plan reviews at city city planning levels, so we could review plans to see if they met building codes and recommend what they needed to do, that sort of thing. We've looked at those things. But the natural resources is where we've been most comfortable, so that's where we've spent most of our time.
Yeah, Philip.
Well, actually, also, just I hope you can hear me there. Just answering an answer to Marco as well is that nowadays, if you're doing natural resources, you're almost invariably also looking at social impacts and economic impacts. So the actual modeling around with NetWeaver is, to me, more and more comprehensive these days. A lot of us worked on a big project with the Corps of Engineers where we're looking at any given service that the Corps of Engineers offers, like dams and hydroelectricity. What is the overall value to the nation? And that was everything from jobs to carbon sequestration and other things. So I think even if you try and stick with natural resources, you'll find yourself going very broad.
Yeah, and that reminds me of another one we did, and it's still an active one. It's for desert locusts, and basically we started off thinking we might be able to help them predict desert locust outbreaks. Well, they had that pretty well under control. What they needed was a system, or they needed help building contingency plans. And it ends up the contingency plans have very little to do with the desert locusts themselves. It has more to do with the kind of government you're working under, social constraints. It's a lot of political factors and social factors. So very much not natural resource oriented. And it's been pretty successful. It really it's helped a lot of countries figure out what they needed to do to be more successful when an outbreak would occur, so that they could know what they had to do to maybe tweak the government the correct way, that sort of thing. So it's worked out pretty well. And anybody's free to apply it to whatever they want to use it for. I'll be glad to give anybody a hand with whatever ideas they come up with.
Okay. Thanks, everybody. We probably better keep moving along here, so I don't take up your whole day. The next one is going to be CDP. This one's a little tricky for me to get started, so bear with me a second. I'm still mastering running a whole series of presentations in this thing. So just 1 minute.
Hello, I'm Philip Murphy.
Okay, just a second. All right. Oops. All right. Just a second.
Hello, I'm Philip Murphy, the designer of Criterion Decision Plus, or CDP as we call it, at InfoHarvest Incorporated, based here in Seattle. In this presentation, I'm going to briefly introduce what's the point of CDP, what's the history of CDP, an incredibly brief introduction to multi-criteria decision analysis, and then a longer demo creating and running a decision model, and finally wrapping up with the next section of CDP, which is amazingly will happen in CDP 5. So the point of Criterion Decision Plus is that it fuses data and human values to recommend the best choices possible in the time available, and then communicates the decision reasoning behind those recommendations to a larger audience. And then as those actual decisions are implemented and their outcomes analyzed, we learn from the successes and failures as we push forward, hopefully building ever better models as we do the same type of decision over and over again into the future. The main takeaway from this slide is that the first version of CDP was the DOS version released way back in 1991, and the newest version, CDP4, has just been released and is primed for use in EMDS7, which is just being released. So CDP is a tool to help people execute a multi-criterion decision analysis approach to decision making. It's easiest to explain what MCDA is by describing the basic workflow involved. Typically, step one is to explore and structure the decision, figure out exactly what the goal of the decision is, identify what objectives will let you know whether you're actually making progress towards that goal, identify relevant criterion attributes which, if known about an alternative, gives you some insight as to how well that alternative supports those criteria, and then finally identifying the relevant alternative themselves. What are options that we can actually choose from in this decision? Once you have done that, you go through a process of eliciting preferences so that you can determine weights for the criteria. You rate the alternatives against the criteria. With all that done, the CDP will then calculate the weighted sum for each alternative. You should then use the CDP analysis capabilities to validate those results. Results can come in two different types. You might have a winner-takes-all situation where the highest scoring alternative is the one that is recommended, or, as Steve will show later, you may be in a situation where you're actually looking for a portfolio of alternatives delivering the most benefit for a given budget. The key to all of this is that multi-criteria decision analysis is essentially a synthesis approach. It brings together disparate information from across an organization. The more strategic the decision, the wider the types of information that will need to be used. Typically, most of the sources already exist within the organization, but some of these sources will be very credible, often the results of significant analysis or domain expertise within the organization. Other items may be entirely qualitative, i.e. strategic fit and legal jeopardy. But no matter the level of confidence you have in a factor, if that factor matters, it must be brought into the decision. Okay, now for the demo. Right, in this video, I'm going to show you key steps in using CDP to create and analyze a decision model. Suppose that we've been given the task of creating a recommendation as to which software project our team should focus on in 2019. We've been given a list of projects. We've been given some criteria already associated with these projects, some of which are quantitative, many of which are qualitative. The software projects themselves range from very simple consulting projects to creating a whole brand new, major new product. So let's start off. Let's copy this table of data that we've been given. Control C for copy. And let's go over to a Criterion Decision Plus CDP4 in this case, which has an empty brainstorm. If I go to the Edit and Paste Special menu, I can import this table, but I need to get it right. Are the alternatives columns? No, it's the criteria that are column headings, and the alternatives are row headings here. So if I pull that in, you can see I got it right, as in the alternatives appear in the alternative list over here, and the various criteria appear here. In the background, even though you don't see it, all of the original data that's in the table is also being kept in memory as we work here. So now I want to sort of design the my decision hierarchy. It's always very important to go down and clarify immediately what is the purpose of this decision, and it is to select a project, a single project here. So let's try and put some, organize this somewhat. Let's zip over here. If I look at revenue, development costs, and the possibility of follow-ons, these all come down to profitability. So I can group these by hitting Control G and profitability. It's right there. And once I have that, these guys can be moved. I can drag them onto selected projects, saying these are definitely the key elements, key criteria I'll be bringing into the decision. Schedule and technical, these could be put together as feasibility. And then at the last moment, some of the upper management shows up to your team meeting, and they want to insist that we should think about whether or not the project aligns with strategic goals, because upper management always has strategic goals. And then at the same time, the staff, the team raises their hand and says, listen, we care also that there's actually staff support for this, for whatever project we're looking at. So let's put these two under overall desirability. Desirability. My spelling is terrible. There is a spell check, but I'm not going to use it because I need to get through this thing at speed. So again, drag that over. So now I have a decision hierarchy, or at least the guts thereof. So what I'm going to do is I'm going to turn this into a formal decision hierarchy. So I press a button up here. So as you can see, I now have what looks like a decision hierarchy. Let's have a quick look at, let's say, for instance, the question of technical risk. I see no challenge, tech quagmire. These are in fact exactly the ratings that we had in the original table, so I know my information was brought across correctly. But what CDP, of course, doesn't know is that from its perspective, when it imported these are just words. We need to make a natural scale out of this, that we can use for decision making. We have to make it an ordinal scale, and to do that, we have to make sure that we have these words organized in the correct thing. Being a quagmire is the highest level of technical risk here. Let's say straightforward. Put it there. Whoops. Hit OK to that, say yes to this, and when I come back here, I now have a scale that goes from all the way from sleepwalk up to a known technical quagmire. Obviously, as you can see, I'm using a very non-formal scale, but it's a scale that means something to my crew. Now, one thing I want to emphasize about any type of ratings when you've got a qualitative scale, some of us, especially scientists, are inclined to be a bit wary of that, but you have complete control over exactly how the scale elements are going to be interpreted here. I can just do them linearly. It goes from basically, if it's a sleepwalk, then there's no difficulty at all under this. Now, one thing immediately I want to change this is negative, because I'm trying to actually figure out projects I want to do. On the whole, I like projects that are easy to do. Ones that are technical quagmires we should avoid. So I flipped the scale. And then if I wanted to, with these value functions, I could make it such that, as long as it's any one of the first 3 or 4 scales is okay. It's only when I get close to the really dangerous stuff like known technical quagmire that I actually have a massive draft up here. So you have a lot of control inside CDP as to exactly how you want to interpret the qualitative criteria. I'm going to now jump a little bit. I don't have time to go through this stuff in detail, so I'm going to jump to a slightly more finished model, so I can then show you some of the analysis side. This version of the model is one in which I've cleaned up all the scales, given names to the levels, and rated the alternatives against all the criteria, and rated the importance of the criteria themselves. So at this point, if I go look at the overall decision scores, these overall scores are weighted sums of how all the alternatives rate against the criterion times the importance of that criterion. In the contributions analysis, you can see the weighted sums in action. It's pretty clear here that the major product gets most of its advantage from profitability. If we drill down to profitability, you can see that most of the major product's advantage in profitability comes from its revenue projections. Look at the sensitivity analysis. You can see that the weight in the model, of all the weights that are in this model, the one to which the outcome of the model, which currently says that major product is your best alternative, is most dependent on, is actually the weight of revenue under profitability. Were I to diminish the importance of that from critical to just important, you end up in a world in which the major product and the popular product are about will have the same score. And if I continue to diminish the importance of revenue under profitability, you end up in a situation where where product 1 would actually be the best alternative. So clearly this is really very much dependent on exactly what's happening in terms of revenue estimates. And finally, in terms of analysis, let's quickly look at the trade-offs of lowest criteria. What you see here, for instance, if I trade everything off against revenue, you'll see that I'm trading $1 million revenue against $1 million in cost, given the scales I have and the weights that I've put into the model to date. If you had an actual accountant in the room, they would be a bit upset by this because they would probably point out that costs are immediate. We'll be spending them this year in 2019, whereas revenue are estimates for 2020, and so they should be discounted. And so you should probably adjust the weight slightly to make revenue trade-off slightly less dollars per dollar than current costs. The more quantitative your model, the more quantitative scales you've got, the more that the trade-offs can give you ways of double-checking whether your weights make sense or not. Finally, you are likely interested in using CDP to prioritize features on a map in EMDS. Steve will show you how that works in action, but it's an important thing to know that in CDP4 you can use the export to EMDS command. So go to the model menu, go to interoperability, and choose export hierarchy to EMDS format. This command does two things. It first checks that the way you constructed your model, the length of names and the type of characters you have in the names are all compatible with EMDS. If you pass that check, it goes ahead and actually exports the entire decision model into a new file with an XML format that you can save and then use and load in EMDS when you go to run EMDS. That ends the demo. And finally, the next steps for CDP. In CDP5, we're hoping to introduce more sophisticated approaches to portfolio management, dynamic uncertainty assignment, sensitivity to ratings, not just weights, copy and pasting of submodels, and the importation of tables of data from, let's say, Excel to the hierarchy, and finally, something that will matter to the Forest Service a lot, the ability to install without requiring administration rights. Thank you.
Okay. I'll stop sharing again for a minute. Do you have any questions for Philip? And you can type them in the chat. A few people have done that. That works great too. All right. No questions? Ah. Good question. So Bob, your Forest Service, if I remember correctly. The Forest Service has site licenses for all of the engines. So NetWeaver, CDP, Genie, and Visirule. You just have to contact me about getting a license. Now, if you are not U.S. government, it's a different story. And by the way, as I mentioned at the very beginning, these are all commercial products, so they do come with a price. You can purchase the development tools like CDP and NetWeaver directly from the companies that provide them. And you'll find links on the EMDS site to go to the companies to check on pricing. Anybody else? Okay, I'm not seeing anybody. Alrighty, we'll keep moving along. The next is in two parts. There's first a brief talk introducing Visirule, and then a quick demo of Visirule. So let me see if I can get this started correctly.
Spencer, and
Okay, hang on a minute. Unfortunately, with the videos, I have to sort of start and then stop them to share my screen before I can go on. However, I think I've got that.
I'm Spencer, and I'm going to present VisiRule. VisiRule is a graphical expert system from a company in London called LPA. LPA stands for Logic Programming Associates. LPA have been working with EMDS for several years now. LPA is a small company who set up in 1981 and have been working in AI, otherwise known as artificial intelligence, since then. In those days, AI had a broad meaning, and the area in which LPA has been working is sometimes called rules-based systems, knowledge-based systems, expert systems. In today's reinterpretation of the word artificial intelligence, AI has sometimes, unfortunately, only become associated with machine learning and black boxes which can tell you what you're looking at. LPA have been working with various businesses and in the late 90s developed a document automation system that was very successful, and that became a commercially available product under the name Contract Express. LPA has been servicing its customers worldwide since its inception in 1981. If we look at a diagram of the domain, we can see that in the top left-hand corner we have the interactive extraction of rules from domain experts. In the bottom left-hand corner, we have the automatic derivation of knowledge from machine learning using induction. In the top right-hand corner, we see the deployment of expert systems as interactive questionnaires. And in the bottom right-hand corner, we see rules being embedded within other processes. So what is VisiRule? It's software, a bit like mind map, a bit like Visio, that allows domain experts to draw models that capture their knowledge, allow them to explore their knowledge and execute that knowledge as a set of logical rules. It's no code in that at the simplest level, you just draw a chart and that's it. Low code, because if you want to, you can actually get inside it a bit and tweak the rules. And actually no cliff, because you can even drop to the underlying Prolog language and control everything. So the authoring tool is a very simple visual point and click interface. And these charts are typically published as interactive web sessions. And the web session will collate the various answers and trigger reports and produce instantiated documents. Here's a simple chart on the right-hand side. The bigger boxes are questions, the white boxes are the available answers, the green box is a start, the red box is an end. Here's another chart with 1, 2, 3, 4, 5. Notice now we're branching, but we're also able to converge. The fact that we have convergence in our tree means the tree is actually a directed graph. This is a far more powerful way to represent knowledge. We can actually extend the logic in the white boxes, the expressions, to be compounded. So we have Q1 equals yes and Q2 equals yes versus Q1 equals no and Q2 equals yes, etc., etc. So we can articulate all combinations of logical expressions thereof. And that is a picture showing 1, 2, 3, 4, 5 different charts. Each chart is dealing with a different aspect of a topic. The idea with VisiRule is that you can represent your knowledge visually in VisiRule, and the VisiRule will automatically generate the code needed to walk through that chart, and that will happen within EMDS at runtime. Thank you.
Clive's presentation is in two parts, so I'm going to pause for a sec to see if there's any questions about the first part. He's going to go on to do a demo of an interesting application here in the next phase. But in the meantime, any questions from anybody? Okay, in that case, I'll go on to the next step. Let's see.
We're going to look at how
Okay. Sure.
We're going to look at how we can get from data to a deployed expert system in under 5 clicks. Let's start by looking at some data. Excel. Here we have our sensors for the various flights over time. We can push this into a machine learning algorithm and it will generate us a decision tree. I'm not going to show you that. That's standard. But what we can then do is export the decision tree as PMML, and then we can import that into Prolog. Let's fire up a Prolog and let's import PMML. Go to disk, pull out one of our many PMMLs and load it up. Now, on the left, we see the XML data with all the nodes, the counts and the splits. And on the right, we can see some sort of internal rule representation. We can save that file as a VisiRule chart, CS4, it's my fourth time lucky. And now we will get a VisiRule chart. Let's get that out of the way and we can see some information on it. And it has an average path length of 6.2. Okay. Here's our chart. We can do what we like to it. So one thing we might want to do is say, okay, we don't really need this. We can delete that. Or we can just check those expressions directly. Okay, we could make more changes, but that's enough. So let's save it, CS4. I will now switch to another Prolog with an uploader, and I will open that file, which was CS4, and we want visual. There we are, top of the tree. Okay, there's the chart. Yeah, we could add in explanations or do other things, but we're just going to push it. So we go to the web, let's call it demo 4, click the right file, and push it up to our VisiRule server, cloud-based server, which will walk through this chart, extract all the relevant bits, and publish us an interactive web-based questionnaire. It will also generate an SVG image of the chart. So we can now answer the questions generated from this chart interactively. Pause. Now we see the chart. First question, let's put in a value of 0.77, and that takes us to the right, and then maybe let's put in a value of 145. So this is all generated dynamically, and it's useful because it helps me remember what values are going to give me a fairly interesting result. So I'm going to put in something greater than 0.3, so maybe 0.35. And then I want to come down the next branch, which would be, say 26. Okay. That should get me to the end, and it will generate me a report, and the report contains a question trail of all the answers and the whole conversation of the session. So that will appear in a file, and the file is stored on the server, and that file can also be generated as XML, and the XML can be passed through to other processes. So let me now pause. What I'd like to show you is we can run this chart as a bot. So if I go to my air handler, I can now run it as a bot. Let's select an air handler, select an airport, and now I'm going through the interactive questions, this time with the neural net plugged in, this time with explanations plugged in, and we're doing the same interactive logic, but at this stage we can ask, well, why? Why are you asking me about numerical sensors? And how did we get to this point in time? So we have a much richer interaction going on here. We could have links. So this would be very useful for maybe advising people what was going on. Let me put in a couple more values, 160, and finally 25, and it will come to some conclusion, and it tells me it's a turbine axle bearings, and it can export a trail of this conversation for me. So there we've seen the same logic deployed in multiple ways. Thank you.
Okay, thanks, Clive. Anybody have any questions for Clive? And by the way, somebody was pointing out their audio on their end wasn't very good. Is the audio for most people okay? Okay. You're getting multiple answers. Okay. Huh. Okay. It's variable. It may be the connections at the your individual locations. I don't know. Where it's originating from, it sounds fine. So I think it might be connections. That's the best I can tell you. I apologize for that. Huh. Okay. Clive couldn't understand it. That's not too surprising, Clive. Well, we'll carry on, see if it does any better with some of the other ones. The next one is the visitor rule demo. Yeah, I agree. Let's see. Well,
You're going to look.
oh, wait a minute, I just did that. Sorry. Apologies. Okay, my apologies. Started to do the same one again. All right, so the next one up is a presentation by Mark Drusdell. This is on Genie, and it's again in two parts. There's an intro part and then a demo part.
Good morning. My name is Marek Drusdel, and I'm one of the partners in Bayesian LLC, which is one of the youngest members of the EMDS consortium. I'm going to tell you briefly about Bayesian, then spend most of my time on Bayesian networks and their relatives, show you one slide of architecture of Genie and Smile, and after the presentation I'll give you a brief demo of Genie. Bayesian LLC started as a research lab at the University of Pittsburgh, where I'm also a professor. We developed Genie and Smile over a period of 20 years, have had several users, and became quite well known for the quality and functionality of the software. In 2015, we formed a company with some of our people, acquired license for Genie and Smile, and it's a commercial company, but we are continuing the tradition of the Decision Systems Lab in making the software available free of charge to academic use. Bayesian networks are acyclic directed graphs consisting of the structure of the graph, the qualitative part, typically mimicking the causal structure among variables, and the quantitative part, which are the numbers composing the joint probability distribution over the variables. The numbers reside in the nodes of the network. In those nodes that have no predecessors, we have prior probability distributions. In all nodes that have predecessors, we have conditional probability distributions, conditional on the predecessors. Bayesian networks are used to calculate the impact of observations on other variables. For example, if we want to know the probability of an invasive cervical cancer in a patient with high-grade dysplasia with a history of HPV infections, the cancer state is in the cervix node, observations are in the HPV and Pap test node. We can imagine that as spreading the information over the network and calculating the conditional probability distribution of interest, answering effectively the question that we are asking. Here is a network demonstrating the power of representation using Bayesian networks. There are over 2100 variables in this model. Brute force representation would require 2 to the power of 2100 parameters. This network is represented by just 12,000 parameters. Let me magnify the middle part of the node of the network. You see that this is a spaghetti of connections. And then the parameters, 2 to the power of 2100 is roughly 10 to the power of 600, which is orders and orders of magnitude more than the currently believed number of atoms in the observable universe. Bayesian networks are very close to equation-based systems, systems of simultaneous equations in which some of the equations describe the interactions among variables and other equations describe settings for exogenous variables. A system of equations like this can be shown by means of a directed acyclic graph. That is work dating back to 1950s. Spreadsheet-based models are also an instance of a relative of Bayesian networks. You can imagine putting arrows between cells that feed each other. Of course, this kind of representation would not be very convenient because that would remind us of a spaghetti of things as well. Directed graphs of Bayesian networks are much better. Our software focuses on a presentation that is a hybrid of systems of simultaneous equations and Bayesian networks. Here's an example of a hybrid network in which quite a number of nodes have equations and continuous distributions in them, and then you can also have discrete nodes and influences that are typical of discrete Bayesian networks. These are hybrid Bayesian networks. Our software allows you also to represent dynamic models, dynamic systems. Here is a somewhat naive, we believe, representation of dynamic models in which we have the same variables replicated in time t and t+1 and showing influences that span over time. The representation used in Genie is closer to graphical representations of systems of difference or differential equations. Every node is represented just once, and we show temporal arcs with labels of the temporal influence. We allow temporal influences spanning over several orders of time, which is a big step towards systems of differential equations with derivatives of various orders. The architecture of Genie and SMILE is quite simple. There is the API, Application Programmer's Interface. C and C++ are native to SMILE. And then we have several wrappers allowing the users to access SMILE functionality from Java, that's JSmile, from .NET programs like Visual Basic, and even on Pocket PCs like Android or Apple devices. And we also have a wrapper for direct access from Python. Genie is just a simple GUI, graphical user interface, working under Windows but also under Linux and Apple Macintosh. I will give you a brief demo after this presentation. The recent developments after we created the company are hybrid Bayesian networks, some of the ideas I showed you in this presentation. We also have an interactive model repository that can be installed at the client's user's site and allows local users on a local network to access the models and play with them. We also have smartphone apps for iPhone and soon for Android devices that allow to use this technology. Very soon, an exciting development for this community is support for map-based applications, spatial Bayesian networks, allowing us to perform calculation on individual grids of a larger map. We're also planning several enhancements to learning, such as learning dynamic Bayesian networks from time series and various algorithms and concluding remarks. Bayesian probability theory works. There are plenty of successful applications that solve real problems. Some people call 21st century the century of data. Others call it the century of Bayes. Genie and SMILE are popular in academia because they are free, but they are also a prime choice for commercial applications, and we have quite a number of commercial users. And it is our users who drive our development in terms of improvements and new features. So we encourage you very strongly to get in touch with us if you need help or if you have any suggestions for the future. Thank you very much.
Okay, just a second here. So, just out of curiosity, since this was running through PowerPoint, is the quality of the sound for people better than the earlier ones, which were MP4s? Aha! Okay, good. That's okay. Everybody agrees. It's unanimous. Well, that's very good. Thanks. It's that's a valuable lesson. So I'm sorry about the MP4s being somewhat of a problem. going to carry on. Let's see. Okay, the next one is, again, this is part 2. This is Mark's demo of G. It's unfortunately it's an MP4, but we'll carry on. Just need to be able to present. All right.
I'm going to give you a 5-minute introduction to Bayesian networks, what they are, how to build them, how to learn them from data, and finally, how to use them in practical applications. We will build a simple network that models an investment decision. We'll create 2 variables, chance nodes. The first one will be named success of a venture. Let's define that variable. We'll give it an identifier success and name success of a venture. This variable models the probability of a business succeeding. Suppose that the probability of a business succeeding is around 20%, which means pretty much that 20% of all small businesses, startups, succeed, and 80% of them fail. That's a prior probability of success of a new business. If we want to estimate the probability of success, we may ask an expert to give us an evaluation of this business. Let's call this variable expert forecast, or in brief, forecast. The variable is going to be defined as the forecast may be good, fair, or poor. I'm going to add another state of this variable to denote poor. Let there be a connection between the two. Typically, we interpret connections as causal connections. This arc, this arrow, means that success of a venture has a causal impact on expert forecast. In other words, the expert is guided by the potential success of this venture in her forecasts. If the business is going to be successful, let the expert give 40% chance of succeeding, the same 40% of a statement that the business is fair, and poor 20%. In other words, for all successful businesses, the expert will estimate them as good with 40% chance, fair with 40% chance, and poor with 20% chance. If this business is going to be a failure, the expert can still make a mistake and call it a good business with 10% chance, fair business with 30% chance, and a poor business with 60% chance. A Bayesian network is a specification of a joint probability distribution over a collection of variables. Once we have this collection of variables, we can perform inference with them. We can reason. The main type of reasoning in Bayesian networks is calculating the impact of observation on other variables in the network. To show you that, let me view these 2 variables as bar charts. At this point, we can see the states of each of the variables and also their probabilities. Success of a venture has 20% probability, failure 80%. Expert forecast That's so-called the marginal distribution. Our expert calls 16% of all businesses that she's asked to evaluate good, 52% of them poor. And now, reasoning in Bayesian networks. I'm double-clicking on the outcome good, given that the expert said that this business is good, the probability of success of this business goes up to 50%. If the expert says poor, again I'm double-clicking on the state poor, the probability of success of this venture is only 8%. As you see, I can use Bayesian networks to calculate the impact of observations on other variables. This is their fundamental way of working. Suppose we have a data set. This data set has been collected at a bank. We are dealing with 10,000 records of bank customers who are measured on quite a number of variables, starting from payment history, work history, and ending at a variable called creditworthiness. Has this customer paid his or her loan back? We can learn a new Bayesian network from these data. I'm picking one of the algorithms which proposes a structure for this network. We are learning this structure. Let me reorganize it slightly. I'm going to view it as a bar chart. I'm going to expand the nodes a little so that we can see what they mean, and then also change the layout of the graph. Here we are. We have a new Bayesian network created from the data set, a Bayesian network that is immediately useful in predicting the creditworthiness of an individual applying for a loan. If this individual comes from a similar population to the population that we measured over time, then we can predict whether this individual will pay back the loan. Typical questions on a loan application: payment history, work history, income. I'm observing these variables, age, and as you see, all of these inputs, the data, are impacting the creditworthiness of the individual. So a Bayesian network that we just constructed can be used immediately in the same way that we used our small two-node network for predicting the success of a venture. We can predict whether this customer will pay a loan. Finally, a very large network consisting of over 2,000 variables, 2,127 variables, used for diagnosis of diesel locomotives. This network illustrates one more application of Bayesian networks. Let me first show you this model. It's an impressive model. I'm going to fit it to the window. Please note that it is really very complex. It models various ways a diesel locomotive can break and various symptoms of different failures of the locomotive. As you see, the network is very complex. Let me demonstrate diagnostic application of these methodologies. I have opened a special diagnostic window in which in the upper left corner we have all possible ways that a locomotive can fail. There are quite a number of them. And on the right-hand side, top right-hand side, we see various symptoms, rank ordered from the most to least informative. Suppose we want to know more about this possible failure, which is the most likely one at the moment. These are the two most important tests. Suppose we are suspecting 4 of these different failures. Here are the tests that are going to be distinguishing among them most. If I choose something that is judged by the program not informative, then not much is changing among the four. If I pick one of the top symptoms, test results that are judged to be very informative, you will see that a lot is changing among the possible failures. This demonstrated a diagnostic application of Bayesian networks, which have been very successful in diagnosis. This concludes my brief presentation. Please do not hesitate to get in touch with us if you have any further questions or if we can be of any help to you. Thank you very much.
Okay. Thank you, Mark. Again, I'll pause, see if anyone has any questions for Mark. And I'm going to need a minute to set something up for the next demo. I got it a little last minute, so bear with me for a second. That one? Okay, that wasn't too bad. All right, we're almost there. I had to load it. Yep. Okay, that's, again, sorry, another MP4. What's that? Oh, okay. Good news is, this is Steve Paplanis. He's the senior engineer behind EMDS Core. He's going to be doing a demo showing linkage between some of the different engines. So this is going to be rather interesting. Fortunately, he's actually speaking. We have the video, but he's going to be talking over it. So hopefully you'll hear the sound just fine this time. Hang on a minute. I've got to have to start it, and then.
Does everyone can hear me? Okay.
Wait a minute. I've got to. Okay. Can folks hear? Okay.
This is the final presentation for the day, and it's to demonstrate an end-to-end analysis with EMDS. By leveraging the power of EMDS with various EMDS engines, we'll be able to do a comprehensive end-to-end analysis of our target area, the Chuakan watershed. The schedule is as follows. We will introduce the Chuakan watershed and the goals of the analysis and demonstrate creating of an EMDS project. We will do an EMDS methodology in NetWeaver integration review, and then we would do a demo to create the assessment and initial analysis to determine the current state. We will view the results inside Hotlink Manager. We will then be looking at CDP integration and demo to create a task to determine the restoration priority of watershed and stream reaches. And then finally, we're going to do an LPA integration review and a demo to create a portfolio to determine which action can be accomplished with a specific budget. The Chuakan watershed is located in western Oregon and Washington, encompassing the Fremont-Winema National Forest. This area is dominated by ponderosa pine, lodgepole pine, white fir, with dozens of smaller streams and rivers. The goal of our analysis is to determine the current status of the watershed and what actions can achieve the following objectives. halt the habitat degradation, maintain ecosystems in good condition, and aid the recovery of freshwater habitats of at-risk fish populations. As we look in our first demo, instead of ArcMap, you notice that there are several layers which make up our Chuacan watershed. For our purposes, the primary two layers are the basin boundary and the sub-watersheds. To create a new project, we click here on the new EMDS project button. This will bring up the Create Project wizard, and we'll give it a name, Chuacan 1. A new project is created and is ready for an analysis. So that finishes our first demo. Now we're going to look at the EMDS methodology, which is a basic workflow that helps guide the user to perform an analysis. The first step, as you've seen, is to create an EMDS project. We will then specify a spatial extent and the data layers that will be part of the assessment. From there, one or more tasks are used to perform an evaluation or analysis. An assessment is the step where we specify the spatial extent and data layers. After you create a new project, the Create New Assessment wizard is brought up. Please note, right-clicking on an existing assessment will bring up a menu where you can create new assessments. For our purposes, we will give the assessment name as Watershed 1. We will add the basin boundary as type layer and the target layer as sub-watersheds. We need to have at least one layer as a target, since that will control the spatial selection. Next. We will select all the watersheds. Click Next. And this will generate an overlay. That will be the base data for all the analysis tasks for the assessment. We'll click Finish to actually create the assessments. Are there any questions at this point? Or what we're going to do then, continue to NetWeaver if there are no questions or clarifications. Going once, going twice. Okay, then we'll continue. Oh wait, someone's typing something. Oh great. Is the interface in 6 similar to 7? Yes, it is. There are a couple of extra options, such as being able to build workflows and a couple of other tasks that we have that are new within 7 that are not in 6, but it is consistent with the 6 interface. Okay. 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 For our Chuacan example, we need to determine the current status of the watershed system. NetWeaver is a great tool to answer questions about the state of the system. NetWeaver knowledge base was created to have such items as reach condition and upland condition. And and an upland condition, which is part of watershed condition, and the stream access and the stream condition. From this knowledge base, we will need to link it to the overlay layer, and that's what we're going to demo next. So back into our ArcMap we go. We will right-click on Watershed 1 and select Add New Analysis. We just select the NetWeaver task, and call it current state. Then we hit next, and we will select the knowledge base file. In this case, it's the Chuacon WS file. And click next. And then we will select which topics we wish to evaluate. I'm going to select watershed evaluation. We can then map the overlay fields to the knowledge base. Since it all auto-mapped everything we needed, we don't have to do it, and so we can just click Finish. So it now does the calculations. And then in order to view the results, we right-click on the main current state and select View NetWeaver Results. Looking at watershed condition, we will see a map with the results. If we click on the watershed on the map, which we will do now, click. We selected it. The NetWeaver model, if you notice on the right-hand side, will display how it came up with the specific results. We will add upland condition and click Add to Map. This will add the layers back to the original map, as you can see. Okay. Are there any does this make sense so far? Okay. Okay, so okay. So now we're going to move on to the CDP integration step. Next step is to create a decision model using CDP to determine the priority for the restoration of the watershed. This is the CDP model that was created. Pretty straightforward, and so we will go right back into ArcMap and create a CDP task. So we will right-click on Current State, Set, and create New Task, and select CDP. Okay, this will open up the CDP wizard. We'll give it name, we'll call it Restoration Priority. Next, we'll select the appropriate CDP file. Hit next, and then we will do the actual mapping of the results from the NetWeaver analysis and from the overlay to the lowest criteria of the CDP model. On all the wizards, we can either double-click on the database field, or we can use the arrows to move to select them. That's something I added with version 7, so that you could do it in either case. So we will give it a unique name, which is this sub-watershed name. Hit next and hit next. And this is all the other information, and then we hit finish to create the prioritization. Okay. The prioritization is now calculated, and the results will be displayed in ArcMap. It does it pretty quickly. And now if you notice that we now have the map of the prioritization scores. However, if we want to get additional details, we will right-click on Restoration Priority and select CDP Viewer. Here we can see the input table, the lowest criteria priority values, okay, the calculations, the contributions, the sensitivity, and the trade-offs. Is this clear, or do you have any questions at this point? No, it is. Okay, perfect. Sorry. Okay, I think that everyone is caught up. Okay, so I'm going to hit continue. Our next evaluation is to look at which of the actions can actually be done with the budget amounts for the project. Leveraging Visual, a model was created so we could sort out and separate the restoration activities. Inside ArcMap, we right-click on Restoration Priority and select Create New Task. We will go under Actions and select Action Priorities. Okay, we will now give it a name, Port 1. We will give it the unique field name. If we actually had a funding bin, we would specify it. We will specify a benefit field. The units will be dollars. I made that a cost field, and then I specified the budget to be $18 million. Okay, then we specify the cost. Click Next. Okay, now here we can make actual bins for funding categories and different budget for each budget category if we want to break that up, but in this case we're going to keep it simple. Now it's going to go out and it's creating and calculating the portfolio. And this will generate a new map when it's done. The other way, maybe that got hidden when I did the screencast. Okay, so if you notice, we have a portfolio Port 1. So the lighter color is the ones that were not in the portfolio, while on the right-hand side are the ones that were part of the portfolio. So the dark green is the ones that are in the portfolio. So this concludes our basic end-to-end demo of EMDS. Yeah, I got one more slide. Oh. So thank you. Once again, my name is Steve Paplanis from Mountain View Business Group. This is where you can reach us. We will have a Days Fusion demo up and workflow editor demo up by tomorrow on our website. So along with this presentation, you will have access to those demos. If there's any questions at this point, I'm open to answering.
Okay, thanks, Steve. Any questions for Steve?
Okay, the interface for the interface for QGIS is actually going to look exactly the same as the one for EMDS. It will match the color palette that is for traditional QGIS, but besides the color palette, it will be exactly the same and have the exact same capabilities. As we mentioned earlier, we plan to have our first public beta at the end of this month. And for all those who are interested, please contact me, and I can add you to the beta list for testing.
Okay. Well, we just ran through all the demos of all the products. So at this point, we're going to open it up for just general discussion. Anything anybody wants to ask or talk about is anything's fair game. And again, if you're not sure how to unmute yourself, raise your hand and I'll show you how to do that.
Also, I will put up on the website this week a copy of all the tutorial information that we use to create all the models that I've shown, so that you guys can do it locally with your own copy of EMDS. EMDS 7 was put up yesterday, and I'll have a formal installer up today. So that will be up, and there will also be an update for EMDS 6 that with the updated installer that will be up today.
Okay. Waiting on Bob. Type any question.
I have a, I don't know if you can you hear me? I don't have a question. I just wanted to say thanks. I know it's a huge amount of work that goes into this and getting everybody all in one place and getting all the parts working together. It's amazing, and thanks for all the effort and the continuing collaboration that goes on behind the scenes that makes it work for everybody who uses
Thanks,
it.
Eric. So we had a question from Bob. I'm going to let Steve handle this one.
Okay, so I've tried to standardize the interface so there is a Genie wizard that will allow you to select the Genie model. It will extract the questions or the necessary data parameters that it needs to answer the questions, and then we have the ability to iterate through a data table just like we do with all the other engines to generate a result on the map.
All right, can you say a little bit more about how it displays the results?
Okay, so that is one difference, because one of the big difference is that with the Genie that there is multiple results per each feature, because as you saw in Merritt's demo, each thing could have multiple variables. So, like where you had successful failure or a venture, and he had the expert, and that had values. So each feature will actually show a table that is unique to each feature that has those results for that. So that is one difference between the Genie interface, well, result set versus the other result sets. So yes, the result sets are a bit more complicated. And that's when I was trying to record the demo for it, to explain it took me about 6-7 minutes, which would put me closer to about 25-30 minutes of talking. So I thought that would be better as a standalone introduction. But yes, that's how we handle it. Does that answer your question?
Okay, just waiting on a question there.
One of the features of EMDS 7 is that it does work with across cultures. So it does work on non-English specific machines, and it also does work on saving projects now on OneDrive or Dropbox or on a network drive, which version 6 had great difficulty in handling. Okay, so great to have.
Yeah, Philip, go ahead.
Hi. One thing I want to point out about that amazing demo that Steve did when he ran through using 3 of the tools is that in the portfolio for the first time, all of our tools currently have worked on a single record. You feed it one feature class element, and it looks at the attributes associated with that and does whatever reasoning it does. But in that portfolio version, it may not be obvious, but for the first time, we're actually looking at the entire set of feature class elements and then trying to figure out groups of them that provide maximum benefit under a budget. So this is sort of, to me, very exciting that we're sort of moving away from one feature at a time analysis and starting to look at more complex analysis across features.
Good point.
We have tried to simplify it as much as possible. It is true with very large complex networks. We will probably need to work with you users to help refine it over time, just because while we try to make it consistent and simple to use, feedback will always be good. So hopefully with version 7 you guys will be able to at least play with it. And one other thing that's unique about version 7 that we were unable to do before, you can actually install EMDS 6 on the same box as EMDS 7. So you can actually have both versions running on the same machine. Before, we would not allow that, but now you can actually run the same 2 different versions of the EMDS. So, as I said, Bob, it's any feedback you have as you use it, I'll welcome it. And if you need any direct help, let me know.
Yeah, and same goes for me. And for if you're having particular issues with any of the engines, I think most of the collaborators on the EMDS development are happy to lend a hand and walk you through whatever difficulties you might be having. Okay.
Yeah, and I apologize for my coughing. I had a cold about 3.5 weeks ago, and even though I'm off of it, I still have my cough. As I said, been very exciting working on this. We're also very excited about the future version. We will have also an open source standalone edition where workflows will be the forefront, and we will allow you to directly do analysis either with the spatial then or non-spatially, so you'll be able to do EMDS workflows even without maps. So you'll be able to leverage NetWeaver, CDP, and non-spatial only, and you also have the flexibility to interact with it initially with like tables and data, and then maybe output a map or output a Excel table or output a chart or even we'll have a basic reporting in where you actually be able to build your own simple reports to start off with until we get some feedback on what type of reports you actually are making.
Okay, well, we're at a little over 2 hours. I guess I'd be interested, or me and the other developers would be interested to hear any of your thoughts for the future. Things you haven't seen that you'd like to see that we might entertain figuring out how to implement. Or just general comments about how it's developed up to this point, and good things, bad things. Feedback would be great.
Yeah. I have a question for Philip.
Okay. Yeah, there's actually very interesting. There's Marlon. There's two sort of ways to do that. There is a thing called linked models at the moment, where you can actually pull the outputs of 4 or 5 different models into a master model. But you do lose a lot of the detail of the individual models in that. And there's a second thing, is you look up in the user manual, just search on the word voice, V-O-I-C-E, about how you can you basically triplicate it. You can duplicate an entire model within a model and give different voices to it. But as for sort of some of the more interesting group elicitation
Okay, oh, we're back. Okay, sorry about that. My screen decided to go to sleep, and I lost the microphone in the process. So we're back. So Philip, did you see Marlene's question?
I did. I was rambling on in answer to it. Did anybody hear that? Because I don't want to repeat it if I don't have to.
Yeah, I heard it.
Yeah, we can certainly catch up separately, and I can give you more. It's definitely something of interest. So if you've got ideas about how you'd like that to work, we have over the years tried different experiments on group aggregation, and I'd love to hear what you might be interested in seeing yourself.
Okay, there was a comment from Mark. He was commenting on the, Philip had asked, I think, about the credit worthiness data, and Mark was just pointing out that if you have Genie, there's a samples directory that has lots of stuff in it, lots of examples.
Yes, that was a response to statement, the questions from Philip in the chat. That's why I responded.
Okay, thank you. Okay. Any more thoughts, comments from folks? And if not, we'll wrap up here in a minute, but just checking to see. Okay, Marco's question, is there any demo of visit rule in EMDS? Not yet, although we actually have developed an application which is up on the LPA site for classifying vegetation, but we haven't gotten it up to this point in EMDS. However, Marco is actually working on a project here this summer that's working on classifying forest productivity using forest inventory and analysis data, and we'll actually have a real example in EMDS for visit rule.
Just to let you know, the portfolio is actually built in Visual. It's actually Visual. So I will put that up. Plus, I do have a video of another Visual demo that will be going up that I worked with Clive on about 4 or 5 months ago. I just haven't had a chance to finish editing the video, but I will finish editing the video this week, and that will be up on the website along with the data set. So you'll have the portfolio for Visual, and you also have a standalone Visual.
Okay, answering Bob's question, he's asking, the demo looks like it took a spreadsheet file and performed a cart analysis. I'm pretty sure, Clive can chime in here to correct me, but I'm pretty sure that that was developed in something like KNIME, KNIME or something similar, to generate the decision tree, which was then exported in, and well, it was imported into Visual using PMML language. So that's actually, we played around with that here. Marco's going to be doing more of that this summer. It's pretty easy to do. KNIME is a very good data analysis package that's open source, and it does things like decision trees, some of which are exportable and can be consumed by Visual.
So yes, we'll put that up on our website on the emds.mountain-viewgroup.com website, and we also have a YouTube channel which it will also be put up there. So we'll make sure everyone has a link to both the website and the YouTube, so you can look at either location for it. That's to Marco.
And Clive is pointing out more generically, anything that generates PML decision trees can be imported into Visual, apparently. Okay. So there's apparently, according to Philip, there's lots of avenues for getting decision trees into Visceral.
Keith, I think maybe if Steve uploads my video, I believe then people can run through that. It's fairly self-explanatory. I think the quality of the sound on the video is 1,000% better than what I heard today. So I can only assume the distortion is due to something with the Adobe Connect interface. But yeah, the nice thing is you can use whatever you like to generate a decision tree. We haven't looked at CART, but you know, that's another consideration. Most of these guys use a variation of C4.5 or C5 based on Quinlan induction. As Philip says, PMML is the key for that. As long as the tree is something you can squeeze into PMML, and that's kind of becoming a bit of a standard that even Microsoft supports. So then that provides a universal way of grabbing the shape of what's being created.
Yeah. There was another, while I'm thinking about it, this is for Brian. A few years ago, when I was first using Visceral, we wrote a model based on a specification from the east side that Paul Sessberg had developed for identifying places where you could do expedited NEPA for forest fire recovery. And that model was built and exists. If we had the data, we'd have a good example of a Visceral application right now, because it was basically designed to use some fairly simple kind of yes/no answers to navigate through a decision tree to figure out whether you could do an expedited NEPA process, and that would be an easy one to get into EMDS.
Okay. And for Eric, I did the workflow demo kind of off of the data set I got from him, a slightly modified version, so I will be getting that back to you tomorrow, finally. So thank you. And we will have a copy of the presentations, so we will have the full meeting, and we'll have the individual demos also on the website.
Okay, well, we seem to have exhausted the questions. Are there any last questions or comments before we adjourn this session? It's looking like, oh, wait a minute. Philip is typing. Yes, sorry about the difficulties with the MP4s. They were a little fuzzy. That was unfortunate. I think I might have learned a valuable lesson here about sticking with, apparently, PowerPoint worked pretty well.
We all appreciate all you for attending and your feedback, both during this first user forum that we've had and also over the last several years.
Yeah, and by all means, feel very free to get back to Steve or I or any of the other EMDS development team with any comments or questions after this. Thanks, Eric. You're good. Thank you. You're very welcome. Well, now we're getting more comments.
Where you send emails for everyone, to everyone?
Oh. Yeah, thank you, Bob. Well, I sent emails. Well, that's an interesting point. Yeah, if you don't go away, I'm going to write down the names because I'm looking at the participant list. So yeah, as far as follow-up, that's an excellent point. One of the things we'll do in following up is send out an email with the a link to the final recording of this whole thing. I do have to go back and kind of do the front end of it because I didn't turn the recording on for a couple of I don't know, 15 or 20 minutes into this whole thing. So I'm still getting my head around how to run this. Well, there's Clive. Can you read them to me? Eric, Gene, Thomas, Marco, who? Mark, Marlene, Nathan, oops, oh, Nathan.
And Sean Gordon.
Okay, Sean.
Okay, and I'm also going to send it to the people who indicated interest, but for whatever reason were not able to make it. So that will be part of the mailing list too, and it'll go out to them as well.
Okay. That's okay. Gene asked an interesting question. I'm gonna have to test the recording to see if it came through crummy. It may be that the recording is okay. I don't know until we test it. But that's a really good point.
We don't fix any audio issues. We have the ability.
Yep. One way or another, we'll get them fixed. It might be a whole new version. Check audio. All right. Well, yeah, we'll check it out. I don't know what the issue there was. Whether it was some people didn't have good connections, or the audio, the MP4 was crummy for some reason. But we'll look into it. We'll figure out how to get it right.
Yeah, and we'll make sure the audio is consistent, so everything sounds exactly the same and clear.
Source audio is too strong in MP4. Okay.
Might have been in some cases.
Alrighty. Well, I think we're coming up on 2 hours and 20 minutes, so I think we'll let everybody go. Feel free again to follow up with me or Steve or any of the other presenters that you saw here today. But I'd like to thank you all very much for attending. This was a grand experiment, and we made it through kind of okay with a few bumps here and there. But anyways, thanks again to all of you for joining. Appreciate it very much, and hope to be dealing with you all.
Thank you.
Bye-bye, everybody.
Bye.